Hello, my name is Jabar Arya Lokhananta. My matric number A23CS4011 and my supervisor is Dr. Nur Aziza Binti Saadon. I'm from Faculty Computer Science, Software Engineering, Semester 2. And here for my title of my FYP, StunCurd, Mobile-Based Stunting Detection System using Decision Tree Algorithm and WHO, World Health Organization Standard. So for the problem statement, still stunting remains a critical public health problem uh, around the world, especially during this time my stakeholder in Indonesia. So according Indonesia government in 2024, there is the survey say that 4.48 million children stunted, and another problem is still still find it hard for monitor because still paper-based screening, so it's cause a delayed detection, and then it cause the health worker face exhaustion and burnout, and other than that, parent arrive without growth record because still manual, and sometimes there is consultation time lost, and early detection prevent lifelong impairments and urgent needs for accessible tools. For the objective, this project has four main objective. First, develop a dual platform system, a Flutter mobile app for parents, and a Vue.js web dashboard for healthcare workers with offline first architecture. And the second, implement a decision tree classification engine based on the World Health Organization Z-score standard. And the third, design a color-coded alert mechanism, green, yellow, red, with actionable clinic reference. And fourth, evaluate the system through 30 more than case functional testing and such usability testing with 20 parents. So for the literature review and gap analysis, I review several existing solutions with WHO Intro is a gold standard for Z-score calculation but has no interface for parent, and our clinical actor model. And other than Primaco, this is a popular Indonesian app like a nutritional classification. And the other standing super app require constant connectivity with the black box outputs. And until for the current system, it still use the paper piece for from the clinic. This is called Posyandu here with a good community reach, but double data entry burden. So to identify the gap, um, there is no offline capable solution for rural area with a limited connectivity, no explainable classification showing decision reasoning to parents, no multi-factor assessment combining all VHOZ score, and no structured data probability, which is can export PDF or CSV for hospital consultation. So, for my proposed solution here, StunGrid is hybrid application system combining Flutter mobile app for parent and caregiver, which is a health worker or nurse, with a Vue.js web dashboard for health worker. The classification engine uses Python Fast API, Python Fast API implementing a decision tree algorithm that applies WHO Z-score threshold for accurate nutritional status assessment. And for the key feature include explainable decision path with color code, alert, green, yellow, red. For intuitive risk communication, the system follow an offline first architecture using SQLite, local storage with Firebase cloud synchronous, ensuring functionality in low connectivity areas. Exportable PDF or CSV reports support hospital consultation. So for the key technical component, we have Flutter, Vue.js, Fast API Python here, and then for the database we will use SQLite and Firebase. Other than that, we can use PostgreSQL or Firebase authentication and HTTPS or TLS, and this is a role-based access. So this is the architecture data model, which is in the Flutter org. There is using for parent mobile, have a child profile data, can scale local database, local kit, and synchronize data to the Firebase. This in the infrastructure layer, and then the Firebase it will send back to the parent to the mobile. And for the backend Fast API, use decision tree engine, which it will be in the use case 11, and we add a VHOZ score calculator use in UC9, and computation rules handler in UC12, and it will auto manager and analytic ingester. And so this how the architecture diagram model. So for the user roles, here we have a three main, which is a parent, a health worker, and system administrator. So for the parent, it will home care screening via mobile app, track child growth history, receive color code alerts. And for the health worker, which is a nurse, it will can access dashboard, access for alert, generate report, manage at-risk cases, and follow-ups for this. And for system administrator, it can use for user management, and we actually reference table updates, or other than that it can analyze monitoring and system maintenance. And for the system development phase, I use plan driven, which is for the phases one. It will be for the analysis, it will gather the requirements, stakeholder analysis, literature review, and feasibility. On phase two, it will design architecture, database, sim, UI, UX, wireframes, and classification logics. And phase three, it will be development, which is the Flutter front end, phase API backend, and system integration. And phase four, it will be testing. It will functional test case as US usability at the hospital. So for the testing evaluation approach, there is 30 plus functionality test cases covering classification accuracy and app feature, and system usability scale testing with 20 per parent in the hospital. And the evaluation focus is usability, offline functionality, and explainability of decision path. So for the preliminary result indicate stable performance and positive parent acceptance. And this for the reference. And for my limitation and challenge, the accuracy depend on the parameter anthropometric mitigate by validation range, which for a height of 45 until 120 centimeter, and with a weight 2 until 30 kilogram. So for the manual input introduce potential measurement error. And this no AFS camera measurement implemented yet, no automated hospital referral or government platform integration, but for future work needed to integrate automatic data capture and referral workflow. So thank you.